Hello, everyone. Thank you for joining us from wherever you are today. Before we, as people are still joining, we're not quite at our beginning time yet. So as people are joining, I would just like to run a quick poll to get everyone warmed up this morning or this afternoon, wherever you are. So we're here to talk about CDS systems, chromatography data systems today. And I am interested in knowing what chromatography data systems you are currently using. So please respond with as many. If you are using more than one, then please choose more than one. And I'm going to leave this up while we have people join us. So thank you to everyone who is responding. If you are, I'm seeing the poll answers as they're coming in. So we have some people who are choosing other, and because we're interested, just let us know, type into the chat and let us know what the CDS is that you are using if it's not one of those that is listed. So thank you very much for that. I am now going to close that poll and share the results. I figure it's always interesting to know what everybody else in the audience is doing. So the question was, as you were coming in, what chromatography data systems do you use? And there is someone chose everything. So that's great. We will be covering, obviously, many of these as we're going through. Anne-Marie will be telling you a lot more once she gets started. And with that, we shall get started. So thank you everyone for joining us. As I said, if you missed me before, my name is Sanji. I am the host for the webinar today, which is entitled Extract the Value Locked in Your CDS. And I am joined by 3 speakers today who are going to be giving you all of the information. And just to introduce everyone, Anne-Marie Smith is the Chromatography and MS Product Manager here at ACDLabs. And before joining us, she worked at Gilead Sciences and Promel Healthcare, where she focused on impurity identification by LCMS and on method development. Richard Lee, give us a wave, Richard, started his career in metabolite identification and metabolomics and developing radiopharmaceuticals before joining ACDLabs. He now leads our new technology initiatives, setting the stage for a new generation of ACDLabs technologies. And finally, Joe DiMartino manages the development of our CMC decision support software, Luminata. Before he joined ACDLabs, Joe worked in drug development at Apotex, where his responsibilities included designing optimal synthetic routes for API and impurity synthesis. And just to go over some quick housekeeping before we get started, we will have a live Q&A at the end of all 3 presenters speaking. So as questions occur to you, please submit them using the questions panel, the Q&A panel in GoToWebinar. We will take those all at the end. As you have already seen, we are running some poll questions throughout the day today. So please participate and share your experience and your opinions with us. That's why we're holding them. Recordings of all of the presentations will be shared by email, possibly later this week or early next week. So please look out for those and feel free to share with any colleagues who are unable to make it today. And finally, we are administering a short survey at the end, so please respond to that as you're leaving. If you would like anyone to get in touch with you, then let us know. And if you experience any sound quality issues, any audio problems, we always find that if you leave and then rejoin, that can often take care of everything. So that's all the housekeeping. And before I hand things over to Anne-Marie, I am actually going to run one other quick poll. So you told us what chromatography data systems you're using. What we're talking about today is extracting value from the data that's in your CDS. So how often do you want to revisit or reuse the data in your CDS right now? So obviously the data is collected for an initial primary use, but after it has been stored and it has been sitting there, how often do you find that you want to be able to revisit it and reuse it in whatever sense, whatever that means to you? So is it every day you want to be able to access it, on a weekly basis, maybe only a few times a month, perhaps seldom, a few times a year, or maybe you never want to use it and you're just interested in this topic? I'm going to leave that up for a few more seconds because everyone's still frantically clicking. So I will wait for you to cast your responses, and then again, we'll take a quick look because I always think it's interesting to see what everybody else said. So I think everyone seems to have finished, so I will share the results of that. So initially, the first person who clicked said daily, and then there were a few dailies, but we seem to have petered out to between every day to a few times a month. Obviously, we have some people who maybe need to access the data less, but that's fantastic. Thank you very much for sharing that with us. And with that, I am going to hand things over to Anne-Marie. Take it away, please.
Great, thanks. Just checking that you can hear me, Sanji?
Yes, we can.
Perfect. Okay. So today, I'm just going to go over the framework for the entire presentation, so all three presenters. So I'm going to cover the importance of chromatography data systems, how ACDLabs integrates with your CDS, and data processing and making informed decisions. Richard will be covering why automation, ACDLabs Spectra's technology, platform for analytical data management, and foundational technology requirements for AI ML. And then we'll finish up with Joe, who will be covering data interface requirements, process and analytical development use cases, and curation on demand. So starting with some of those chromatography workflows with the Spectra's platform. So first off, I should probably tell you what the Spectra's platform is. It's an expert informatics platform for analytical data and analytical data management. The software enables you to standardize formats by importing data from most major instrument vendors seamlessly. It facilitates the marshaling of that data, organizing it in a user-friendly manner that provides access to live data for reprocessing as needed, all while retaining contextual information like chemical structures. Moreover, the knowledge base you create is fully searchable by structure, spectra, and metadata. It can easily integrate with other systems such as your ELN. Now that we've established some of the capabilities of the Spectra's platform, let's dive into one of the specific areas where chromatographic data originates, which is your CDS. So a CDS, or chromatography data system, is a software system that allows you to communicate with your instrument. It can connect to many different instruments from the same vendor as well as other vendors with some limitations. So key functions of a CDS are acquisition and collection of data. So this allows for the automatic data transfer from chromatography instruments. Next up, we have data processing for analysis of chromatograms, peak identification, and quantitation of analytes. And finally, we have the reporting and archival system. So generating detailed reports of the results with the results stored in a centralized database. Now, if you're using a CDS, there's also a chance that you are performing method development. And we also have interest in method development. So we're going to launch a quick poll just so we can learn what type of method development software you're currently using. And Sanji, I'll get you to launch that poll. Thank you.
Yep. So I have put that up now. So the poll question that Anne-Marie has just prompted is, what method development software do you currently use? There are a few choices there: Fusion, DryLab, ChromeSword. Are you using one of ACDLabs method development software solutions, or do you not use any? Perhaps you don't use anything and you use your own expertise and experience. If you use other software that's not actually named here, that, you know, there are many, those seem to be the main ones that we come across. But if you're using some other method development software, then please go ahead and let us know what that is in the chat. It's always interesting to see what you have, what you can get your hands on, and what you find useful. So I'm going to leave that up just for a couple more seconds as people respond. And I'm going to bring that to a close. And there are some interesting answers. So there is some use of dry lab. We have some ACDLabs software users for method development, and most people seem to use none. So nobody put in the chat that there is another piece of software that they use. Either you're shy and you don't want to share, or you're using your own experience. How do you find that, Anne-Marie? Is this something, you're obviously talking to chromatography customers all the time? Do you find that most people are not using software for this?
I mean, when I was in the lab, we were mostly using our own expertise and just starting to look at software. And I find now a lot of people are looking to software to help. So maybe we just got a shy bunch today.
Okay, I will let you continue. Thank you, everyone.
Thanks. So now that we've learned a little bit about maybe what method development systems you might be using, let's go into a little bit more detail on the CDS that you're probably using to collect that data, regardless of whether it's method development data or not. So with any system, there's going to be pros and cons. So let's go over some of the benefits that CDSs have. So automation of data collection. By automatically collecting the data, this reduces manual intervention and human error. We have data consistency. So the protocols can be standardized, which enhances the reproducibility and comparison between results. We also have the reporting capabilities. So CDS systems have several report options that can help summarize your data in a bit more of a systematic manner. There's also the regulatory compliance side of things. So these systems have detailed records and audit trails that help ensure compliance with industry regulations. And finally, integration capabilities. So the CDSs can connect with various instruments and other systems like LIMS systems for centralized data management. Now, like I said, any pros, there's going to be some cons. So some of those challenges that you might encounter, instrument connectivity. So not all instruments may be compatible with a single CDS system. And so this would lead to integration challenges as well as disparate systems, which have the added drawback of needing to learn another piece of software. There's also costly implementation costs. So the initial setup and maintenance can be quite high, especially for smaller labs. The complexity of use. So some systems, as they're expert systems, they can have quite steep learning curves, which would require extensive training. And then finally, limited contextual data. So it might not be possible to provide the necessary context for comprehensive data analysis. For instance, your chemical structures will be stored in a different place. So how does ACDLabs help with your workflow with getting that data out of your CDS? Well, we extract the full analytical data from your CDS. This includes your tabular, chromatographic, and metadata, as well as having the option to associate chemical context once you're into our platform. So those are your structures, which lets you get that additional insight from your data and make more informed decisions. So we have a variety of ways that the data can be extracted to suit your needs. Some of these have automation possibilities, which will further enhance your workflows, and Richard will cover that shortly. In terms of the CDS systems, we do have coverage for all major CDS systems. So Shimatsu Lab Solutions, Water and Power, Agilent Open Lab, and Thermo Fisher Scientific Chromelium. In addition, as was kind of shown earlier, we maintain partnerships with all major instrument vendors. So all of your data, including those discrete files, can actually be stored in one system. what would that workflow look like if you were to now extract your data from your CDS and use it in ACDLabs software? So from the CDS, whichever CDS or combination of CDSs you're looking at, the data could be automatically pulled if you chose, and that could be either your pre-processed data or with processing that was performed in your CDS into the platform. At this point, you can add your contextual information, so that's structural information, and there's actually additional tools that we won't cover today that can help with structure confirmation, structure elucidation. And all of this processing that's done is being tracked and stored. So at this point, the results can either be reported using a template or customized results and stored in the database. And that database can be searched by structure, spectra, or metadata. Now, this processing also has the added benefit of it can be performed in modern web browsers, which has several benefits. Just to name a few, the overhead for IT, easier user management, and better accessibility for users. This is our Spectra.js platform, and it's a newer platform that we're quite excited about. Now, as we transition to Richard's presentation, I think we're going to launch a poll on how you want to use your CDS data beyond the initial purpose. And Sanji, I'll get you to launch that poll and pass things over to Richard.
Fantastic. Thank you very much, Anne-Marie. So, as Anne-Marie said, tell us a little bit about how you want to be able to use the data that's in your CDS. Perhaps you're already doing so, but beyond that first use of the data that goes into the CDS, how do you want to be able to use it? Is it for reanalysis or reinterrogation somewhere else, somewhere other than the CDS workstation? Is it to generate reports? Do you want to use it for business analytics, statistical analysis, to find out, what kind of, how often instruments are used, how much they're used, which ones are used perhaps, or like there is so much interest in this area right now for AI and ML. So you do want to be able to use the data that is in your CDS for data science initiatives. And if it's something else, there's always something we haven't thought of, then please tell us what that something else is. You can type in the chat window if you want to tell us things. So please go ahead and tell us what that other use is for those of you who are choosing that. So I'm going to leave that up for a second more. And then there we are. Richard's already going to share those results. That's really interesting. So it's not surprising to me that report generation is a big one, because that's something that we hear all the time. And then there seem to be an equal number of people, around 60% of the usage is for either reanalysis or reinterrogation of that data, or for business analytics. And then there's about half of you who are also wanting to use it for data science, and then other uses. Richard, what do you think of those results?
It's not too surprising. I think eventually that AI ML initiative option, I think you'll see a lot more people and organizations move towards that as they want to leverage a lot of their legacy data as well as the newly acquired data. So as a first use case in terms of generating reports and reinterrogating that data, I think that kind of makes sense for now. But you'll notice, I think, as the time progresses, a lot more organizations will want to use that data for AI and ML.
Fantastic. Thank you, everyone. Over to you, Richard.
Thanks, Anne-Marie. So what Anne-Marie spoke about in the last few minutes was really discussing how the end user will interact with that data. The scientists in the lab, they'll need access to chromatograms, spectra, tabular results, how they want to interact with it in terms of whether it's a Windows client or a web browser, but it is all very manual in terms of picking out that data, which data set within that CDS system, and how you want to visualize it. So what I wanted to do was kind of discuss how do we automate this process, and what are the technology considerations that you may want to take, especially when you're looking at automation services for CDS systems. We know that CDS systems are essentially a workhorse in any lab. They're found across every chemical-related industry. It's fairly ubiquitous across any department. So whether it's in discovery and development for pharma, manufacturing, process chemistry, R&D, they are the essential analytical scientific instrument. And as the workhorse, they will acquire the most amount of the analytical data. So organizations, as I mentioned, they want to leverage this data because it's so rich and it's so vast in terms of the amount of data that's been captured. So a lot of organizations want to leverage this data for further downstream use, especially with AI and machine learning. And in order to do that, you really do need automation services that will be required to extract out the relevant data from each of these CDS systems and push it downstream for AI and ML. But in order to do that, you need these automation services services to massage that data or reformat and re-engineer so that they are amenable for these AI and ML frameworks. So I wanted to touch on a few technology considerations and some of the challenges that you may face as an organization. We know that data is dispersed across an organization, right? So you could be in different labs within the same site. You may have different geographic locations. You could be on the other side of the globe, but still work within that same project. The data itself can be stored in many different informatics systems. So if one site is normalized on, let's say, Empower, another site might be normalized on Chameleon. So you have two different data sources that are not interoperable, right? You can't share that data between organizations. So we have data consumers who have difficulty accessing that data on demand when it's ready, when it's required. So you need these automation services to be able to monitor and transfer to the appropriate systems and to really deliver that data when the data consumer is requesting it. And we've touched on the scientists in the lab, right? They need that data in terms of chromatograms, spectra, maybe some method information. If the data is processed, they need tabulated results. And they want to see that in some sort of interactive interface. Right? They want to see it. They want to perhaps reinterrogate that data. But we also need to consider now, especially as we're moving towards this AI and ML paradigm, data scientists need data as well. And the challenge is that the data sources are the same. So for the data scientists as well as the scientists in the actual lab. But the way that the data scientists will interact with that data is quite different. They need data to be abstracted from the actual analytical data set. So they need metadata, they need tabulated results. They're not so much interested in the chromatograms or spectra. So automation systems should be able to deliver what the data consumer requires, regardless of who they are, but from the same type of data source. Right? So automation services should be able to address this. We also have to take a look at whether or not these automation services can provide processing, provide the data provenance, and the contextualization of this analytical data. Right? Scientists need more than just a static report. Right? They want the full interactive analytical data. They want to see chromatograms, spectra. They want to be able to reprocess that data if required, or even perform the initial processing. We also know that analytical data is not enough. A singular data set, it does not provide enough context for that analytical data. So you need information from other systems. So whether they're LIMS systems, ELNs, registration systems, they need data from other informatics systems in order to make that analytical data be more relevant and be more valuable for the data consumer. So the automation service should be able to consume, interpret, and assemble that data together, right? It should be able to retain all of the metadata from the original data file, provide functionality for processing and interpretation, but also be able to pull together metadata from other sources, possibly assemble data sets, multiple data sets together to tell that chemical study story, right? So it's more than just being able to extract data and present it to the data consumer. You really need that data to be contextualized and assembled for the actual data consumer, whoever they are, whether it's a data scientist or the chemist in the lab. So in terms of some considerations that you may want to take when looking at automation services, especially for extracting data from a variety of CDS and informatics systems, the automation service should be able to consume the data across a number of different vendors, right? So whether you're working in Empower or OpenLab or any of the other CDS systems, it should be able to connect seamlessly to be able to pull back the same type of data, chromatograms, spectra in full fidelity. So all the data points, all of the metadata, any of the processing results should be able to be extracted. If required, it should have some basic as well as advanced data processing and interpretation tools. Right? For the scientists, you want to have a fully developed interface so that they can interact with it. So again, peak detection, integration, any type of manipulation that you may want to do should be available. In terms of technology, the system should be able to work across your IT infrastructure, being able to scan data in one location and then be able to transfer it across your IT infrastructure to another location, to be able to automate any of the processing that's required or any of the reporting, and most importantly, be able to pull together metadata from different locations to be able to contextualize that analytical data to tell that chemical story. And then other technology considerations is that you should be able to, the system should be able to be accessed through the web. Right? So again, for data accessibility, the scientists in the lab should be able to access any type of workstation and view that data that they're looking for. As IT groups are moving towards the cloud or in the cloud now, the system should be cloud deployable. It should be able to scale also. So as you're adding more instruments to it, to your organization, the automation service should be able to scale accordingly. But also it should have APIs available for the data scientists, right? They should be able to access that data that's stored within our platform or any platform to be able to extract that and abstract the data that's required for them. Right? So these are some of the technology considerations that you may want to take when looking at automation services, especially as you're kind of moving towards the use of this data for more business intelligence, but especially with the trend of moving towards AI and ML. So what are the automation services that we provide with the Spectra's platform? Right. So before I touch on that, I wanted to kind of speak on where our technology lies, right? So this is a digital hierarchy of needs, right? Where at the top, you have the digital twin. So these are the predictive models that you eventually want to create with the data that you have acquired. But you have to start at the bottom, at the foundation, where you have basic needs for the analytical experiments, right? So being able to have systems in place that will provide the data import, the data conversion, being able to provide the basic processing tools for the analytical data. You have the next layer up, which is integrity and security. Being able to store that data with full audit trails, having the data consumers have access to that data within that database, and then the productivity and collaboration layer. Again, that is being able to have automation services, being able to automate a lot of the back-end processes to increase efficiency, as well as the data assembly, so that you can push that data downstream for AI and ML frameworks. So ACDLabs, we actually play in the foundational layer, right? We provide the basic technology that will allow for data to be consumed, but also engineer and reformat that data to be used further downstream. So that's where we live. So this is just a quick architecture diagram of our technology. It can be more in-depth, but I want to kind of give you a flavor of how our technology works. So at the top layer, we have your instruments. In this case, we have CDS systems. We have automation services that will hook into the CDS systems, scan the data sources, be able to extract out the appropriate data. We can provide the data marshaling, data conversion, any processing that's been required, export that data to a different format, such as a JSON for machine learning if that's required. Also provide the data assembly to provide more chemical context, and then be able to actually integrate into other informatics systems as well. For the scientists in the lab, they can access that data through a number of different interfaces, regardless of whether it's a Windows client or a web browser. We have different applications that support different workflows, such as Catalyst and Luminata, that Joe will speak on a little later on. But we also have web technology that will enable you to integrate our tools into a third-party application. So again, if you have your own web-enabled technology, we can certainly work with you in order to integrate our viewer into those types of applications. And then the data itself can also be stored and accessed through Spectra DB, and that's where we store all of your analytical data. But the data can also be pushed to data lakes or data warehouses, along with cloud object stores if you're working in S3 buckets or Azure, Comet, or Google Cloud. But we talked a lot about how the scientists in the lab will access that data. But for AI and ML to access that data, you need to have tools in place for the data scientists and the machines. And in this case, we have a full suite of Spectra's APIs that will enable you to access our systems, but also access your data. So your data is never locked, and you're always able to access any of the required data for downstream use. You have access to the data through configurable database views, or through APIs, or simply just using our native export feature that will export your data to JSON, which again seems to be the data format of choice for AI and ML. So you have different levels of data accessibility. So again, for the scientists in the lab, through your browser or Windows client, but you also have access for your data scientists as well as machines through our APIs. So I just wanted to give you a quick example of our automation services that are currently deployed. So this is a one solution that's been used within our Luminata application area that supports CMC decision making. So in this case, we have different informatics systems, whether it's a CDS, iControl, which is from Mettler, Toledo, that is a reaction monitoring system, ELNs, and LIMS systems. In this case, we have our automation services that will extract out the metadata from ELNs and LIMS systems with regard to experiment, reaction schemes, sampling information. We can pull that into our Spectra's environment. We can access the results from your iControl reaction monitoring system. So we can parse through that information. So again, we can look at all your reaction conditions and be able to correlate as a scientist in the lab is extracting in-process materials that will want to run them on the CDS system in order to see how the reaction is progressing. So we can correlate the metadata from the iControl along with the CDS data acquisition. So again, being able to match up the specific data set within the CDS with the actual metadata that's being extracted from iControl, ELNs, and LIMS systems, and pull that all together and assemble it within our Spectra's environment. The users, in terms of the scientists in the lab, have access to that data. They can query by ELN experiment numbers, LIMS number, iControl sampling number, as well as any of the metadata that's been extracted from the CDS system. They'll be able to review that data, also to reprocess it if they want to. But all that data is also accessible by machines through our APIs or by a simple JSON export. So this is one example of how our automation services are being used today within the Luminata solution area that Joe will discuss in more detail in the next few minutes. But hopefully, I've been able to show you that the Spectra's platform can be integrated across your IT infrastructure and can be integrated with our automation services so that it can connect all of your analytical data with any of the metadata across your informatics systems. Thank you.
Thank you, Richard. So I think we're going to go into a quick poll just as Joe pops back. And the very last poll question that we're going to launch today is, how do you currently share your data? So you all indicated that you are using the data, that you have particular uses that you want to make of the data that is in your chromatography data systems. How do you how do you currently share it? Do you share it by exchanging PDF documents, using Microsoft Office applications? Excel is a very popular one for, tabular chromatographic data. Are you emailing data between colleagues? Do you do the old-fashioned just have a conversation with someone? Or perhaps there are other methods that you're using. And obviously, I was going to say Microsoft Office and Excel is a popular one. SharePoint is one that lots of organizations are using as well. So we're just interested to know how you're doing it today. And I think most people seem to have responded. So I'm going to give it another perhaps 3 seconds, and I'm going to close it and then share the results. So unsurprisingly, Microsoft Office applications are available to us all, and we all use them to share all kinds of data, PDFs, email. There are obviously some things I missed. You talk to your colleagues, you talk to the people that you work with. I'm interested in what some of those other might be. Perhaps someone can put it in the chat and tell us what some of those others might be. Joe, any surprises there for you? I know you have lots of conversations with customers around this topic.
No, not at all. I think the biggest things that we've seen, and I'll go through this with my talk, is we spend a lot of time just taking that information, but we have this, let's say in the Microsoft Office application, but we're still talking to someone, we're emailing them because it's still not standardized. And I hope that's what you get to see in my talk of how really ACDLabs can help in this standardization. So really the whole next 10 to 15 minutes is just leveraging the CDS data that both Richard and Anne-Marie have talked about inside of analytical development and process development. But really, what interface, what would you need in that application? So just like you heard, you have the software now where everything's been automated. We placed everything within our applications, but what do you need? And what we've seen is the ability to access and assemble and contextualize data sets, like Richard said, being able to really understand what's occurring. From there, browsing and doing comparative browsing. The ability to not just look at your CDS, but look at your material, all the physical chemical properties, all the other analytical data sets that are there. And talking about comparative browsing, that's a big thing if you're looking at analytical development and you focus on any type of material study. As you'll see later, I'll talk about force degradation studies, being able to look at every study that you've done for a drug product and identify a particular degradant or impurity. In that case, querying data sets using various scientific data terms. It sounds easy enough, but you see with Richard's slide, if I'm using an electronic notebook, I have my metadata there. If I have my lab reactor from Mettler Toledo, I have all my metadata. And if I want to search down within Chromeleon, I'm looking at a chromatogram. How can we leverage that all in one interface to really help the user before going into that next step of AI and MLDL frameworks? From there, querying data with data. Again, sounds fundamentally easy, but if you're working in a global team in the US, Europe, Asia, the ability to just look at all of your different CDS systems and just understand what occurred. Have I seen this peak before? What gradient, what method did we use? Did we use a different instrument? All capabilities that once you have this and leveraged it in one area, it just makes it way simpler. And then really from there, the key crucial capability is curation on demand. Just like you've heard, we now have our data, we've curated, we can publish these results, and then we can really have these different types of views to share with our colleagues or different teams as well too. So just having these sorted and pivoted tables and then socializing those results either through JSON, CSV, etc. Process development. So again, this is just a classic data shape, and just like you've heard, what we want to focus here is through the responses, right? That's the toughest part. Once you've talked about automation, you have all the information from your CDS. What do you want to get? And you'll see here, you can have your experiment info, your experiment identifiers, different factors and levels, but you want the responses. What's really crucial is that within these cases, you may have value for theoretical yield, stoichiometry, which are, again, important variables for model development, but the responses are the hard part. With one of our ACDLabs informatics applications, we deal with the instrument signal to the results. When you process and interpret data and relay it back to the experiment, this is the so-called provenance of the digital twin, just as you heard from Richard. Being able to have these variables for particular experiments and then associate the responses is a time saver, where you can have trust in these responses. That's the big thing. From that survey question, sharing of knowledge and having this in, let's say, in Excel becomes such a greater issue if it's not standardized, and any times where you can have transcription issues. And that becomes difficult when you want to do that type of AI work. Being able to trust your responses is a crucial thing, and that's what we really offer within our platforms. So in the case here, once you do and have looked through and published your results, curated results, sharing this information with other colleagues through a JSON format, and really making this mobile. You can choose any format you want to export it to, and then sharing that within those third-party applications and BI software applications as well. Now, this is just further on top of that for process development, focusing on process control justification studies or batch control studies. As you can see in this illustration, the user will probably plan the experiment, process chemists will probably plan it through their electronic notebook, and once they're done the planning of their particular one-step reaction to control, start executing these different templates or sequence files in all of their different instruments. In this case, a lab reactor such as EasyMax eye control, the cases where you can take aliquots at differing time points to have that associated with the CDS. But then once you, again, execute this information, it's all scattered, it's all siloed. And then the end user will have to standardize this by taking this and, like you saw, just copying and pasting, putting inside of Excel, maybe even taking images, and it just becomes difficult to manage because you're doing this one batch process control reaction, maybe 50, hundreds, 150 times. It's just very difficult to get through. So by offering a step where you can curate the data and then decide what's the next step, and that's the big thing is once you do have data together and it's contextualized, making decisions from those contextualized data sets. So in this case, this is an image of the software. And what you'll note within the software, automatically, it's going to create an in-process map. So crucial thing here is you're looking at these windows of all different pieces of software included in one application. So capability of having your in-process map, and you'll note that within the in-process map, that takes from the lab reactor differing time points of interest, and then from there as well too, the capability of viewing your chromatogram. Now within your chromatogram, you can also take in within the peak tables. So within the peak tables, within every column of your time points in the in-process map, view any registered compounds or any unknown impurities in this state. So that capability there, just seeing everything that's been collected per time point is crucial. On top of that, viewing the trend plot that's coming from, let's say, eye control. Seeing any trends that you've done, if you're looking at particular parameter settings such as pH or different temperature jacks, viewable here. And then finally, taking the kinetics of the reaction. When has the product fully been formed? What's that time? Has all the starting material been removed? And viewing that all together. Again, in cases here, having a one-stop shop to view all of your studies in case of looking at your process control evaluation. On top of just looking at just the in-process map, the software allows you to do endpoint maps as well when you're looking at these type of studies for process development. So it creates this endpoint map from your chromatogram. So in this case, again, if you have any compounds associated here, you'll see the compounds, but everything else from the peak table will be viewed within this logical map. And that's a crucial thing, contextualizing data. Now from there, being able to have your tabular views, but not just your tabular views, leveraging information that's coming in from the lab reactor, which you'll see within the operations recipe, taking that metadata here and viewing that with the chromatogram, all in one location. Just simplifying your screen where you understand what's occurring and really evaluating what has to be done next. And if any impurities can't be removed or in their specific specifications that you need to evaluate or if they're genotoxic, it can be done here. Material studies. So in the case I've been talking about has been for really process development, but the same holds true if you're talking to any team in analytical development. And again, the focus here will be force degradation and stability, but you can see from, again, this illustration, you'll have a complex material. And when you have this complex material to do like any type of studies, such as acid, base, thermal, photo, heat, light, it just becomes difficult to manage. And on top of this, you'll see that when you're doing any type of degradant study, the capability here is you're not just looking at all the actual degradants that are coming from the CDS, but you'll have all of the theoretical degradants that you probably predicted through third-party software as well too. How is that being shared? How do you utilize that? And really, this causes issues when you try to collaborate and coordinate all of this type of data. And again, this becomes very difficult to manage if you're talking about teams that are global. Has this been done before? Have we seen it? Are we duplicating? Really minimizing this portion of the work for your force degradation studies. And again, what you view here is the capability of just taking that particular material and creating a bird's eye view. And that's what we call within our project map. So at the highest level, you have the project name. In this case, we call it agomelantin. And you'll see down at every level, okay, where are we focused on? Oh, we're looking at the drug substance, the drug product, all the differing solution or solid states, and then finally the studies that we're reviewing and the capabilities of seeing how far along that study has been done. Everybody in the team can view this, understand what's occurring, and be quite useful. And by clicking on any type of study, you'll see that automatically what's been created is a logical material map. So for the end user, they can see a specific study that was done for acid and understand what's occurred within this study where you have your map and all associated degradants in that case. So just by clicking on a degradant, you can view it and a chromatogram. But what's more powerful here is, Again, the communication of these degradants in these studies is that the user can click on any of the degradants that you view and then go back to the project map and see a blue rectangle to associate where other studies has it been seen. So just imagine the capability, instead of going and communicating with colleagues and just being like, oh, where have we seen this before? And that takes a lot of time. You go through Excel, you're going through your CDS system, you're trying to understand if you've seen this degradant and it's met specifications. In the case here, you can just click and view all of the different studies that one degradant has been viewed before. On top of that as well, being able to click on that degradant and seeing that it's not been seen at all, I think that has value as well too for the end users. This is a new degradant, we'd even predict it. This becomes quite useful just to have an overall view of everything that's been done for this particular project. Now, on top of that, not only are you getting your logical map, you're also getting your logical tables where you can look at and compare all of the different studies for this particular project for force degradation. And crucially here too, having your chromatogram where you can overlay the data. Again, sounds easy enough, but this becomes quite difficult to manage if you're trying to find result ID and understand what's occurred and just overlay this and see the metadata of the experiment, which may not be associated within the CDS. But from there as well too, we're talking about force degradation, looking at a particular material, we can further browse downstream. And in this case, taking that material and understanding all data associated, just from the CDS, but also from the physical chemical properties and all the structural properties as well too. So having an interface where, again, same layouts, same views, but just changing and understanding you're not just viewing the proof of composition, seeing the chromatogram of interest, but also the proof of identity, all of the processing that's been done, where you don't have to reprocess anything if you don't need to, and then being able to just have all of your assignments in one place. This is the power of just having that capability of taking your chromatogram, associating any type of metadata, and then being able to search that information. Now, from here as well, just like I said earlier in my talk, taking data and searching with data. Where have I seen this one peak before? Have we done this chromatogram? Has any of my colleagues, are we using several different CDSs? What's occurring? So again, our capability of just saying, I'm going to look for a specific peak and I want to make sure that it's under this specific specification. So in the case here, I just click and I just have the ability to be like, okay, I want to just look for this type of chromatogram method, any type of metadata, anything less than 0.9%. And what the software allows you to do is, again, view the number of hits, but also visualize all of the details. So you have the hit query in the background, an overlay of the chromatogram, and a better understanding of what's occurred. Again, saving time for the end user before going to the next step of their curation or publishing of the results. Now, from here as well too, doing comparative browsing. Why is this crucial? The capability here, and you'll see that I've highlighted this particular column of all the different studies that we've done for this particular project for your force degradation. So being able to view the material studies and seeing all the numerical values. But again, on top of that, if you don't want to just view the values for your class that you're doing at any time right now, being able to overlay the results. Overlaying those chromatograms and identifying those particular degradants of interest. It's really one click away from just getting the information. And again, instead of just getting a PDF and looking through, which becomes quite difficult if you're trying to zoom in to a really small peak and understand that genotoxic impurity beyond characterization. And again, this has been all very useful for looking at data and going through the CDS, but one of the other things I want to focus on is taking this real data that you've obtained from any of your CDS systems and leveraging that into modeling. So just for a brief background for everyone here, I'm talking about accelerated stability studies. And again, classically, this would take 2 to 3 years to complete, but in the last decade or so, we've been really focusing on accelerated predictive stability studies, so APS studies. And that usually generates a timeline of about 2 to 3 weeks. But the crucial thing that you'll see here is that there's no transcription. So what's being done right now currently is a user going to their CDS, copy and paste, maybe transcribe this into an Excel or another software application. But again, they're doing this manually and they're doing this per degradant. The capability here within our software application is we have the usage of just selecting the temperature, time, relative humidity, and just automating this for all those time points. And once you've automated this, what it creates is, again, the same type of map. So in this case, we create, instead of a force degradation map, the capability here of seeing a accelerated predictive stability map. So again, this logical view of what's occurring. And every column here just really associates all of the differing time points that you've seen, any registered compounds, but crucially the impurities or the degradants in each case, either named through their peak table or understood thoroughly, just all the information you've collected from the CDS being stored here. In the case as well, not just creating this type of map, but having this logical table. You'll see in the first 4 columns, that's all the metadata that we entered, but everything else is coming from the responses from the CDS automatically. Nothing is being transcribed, and you can't actually change any of the results. These are all values that are coming in from the CDS. And crucially, once that's completed, the ability here to just narrow down and understand all the degradants of interest. Again, like I mentioned, right now, if you're doing this into any other software application, you're going to have to put in the values per degradation for your study. In this case, the software allows you just to select a dropdown, look at the degradant of interest, and once you've looked at a degradant of interest, use the modified version of the Arrhenius calculation to get all your values and also to do your modeling. And within the software application, it gives you a quality score of the quality of the modeling, and being able to now just reflect that by changing and modeling the temperature, relative humidity, and time, and getting that understanding of this is how much degradant will appear in 3 years if we made these changes to these variables. And that's all done with the data that you've obtained from your CDS. So really, curation on demand. The capability here, just like you heard from Richard, is focusing on the physical twin where you have your design, you've planned, you've executed, you've reported everything, but making sure in our case, what we call digital twin, where you can take all the metadata that you've seen from the experiment, have the analysis that's been done within the CDS, a storage location where you can view all of this, publish and curate your results, and then having this accessible. Once you're happy with the results, then you can share it. But being able to make these decisions, then you can decide to bring it into any type of MLDL framework. So in this case, just to summarize this portion, having these views to browse, comparative browse, creating these sorted and pivoted tables, and then socializing the results through any type of JSON or any type of format that is needed to be shared to, let's say, a BI interface such as Spotfire. So really to summarize, as you've seen here within the ACDLabs platforms, the capability here of just being vendor neutral. So allowing the user to just be like, we're not just working with one instrument type, we're working with several, and being able to capture all of the metadata in one location. Something that really Anne-Marie emphasized, and really our applications are evolving into a web browser base, which allows this to be ingested easier for the end user as well too. Now from there, once you have added the CDS chromatograms, the capabilities here of also automating this, which was what Richard really focused on, and having this seamless for the scientist. So for the scientists here, being able to place and view everything where they haven't done anything in the background. It's all been automated. They can review the results. And really, that's the portion that I really want to focus on, is once that you have reviewed the results, you can do any type of studies that you're focused on. It could be about the reaction. In this case, we talked about some of the process development work, such as ACD, capabilities of looking at force degradation and material studies, but at the end, also using that beyond just characterizing. Just the ability to also use this to leverage it through any modeling capabilities, such as accelerated predictive stability. So again, from our end, thank you for your time, and look forward to any questions.